Welcome back to Monitors Unboxed. If you bought a DisplayPort 2.1 monitor and hooked it up to a DisplayPort 2.1 graphics card, you'd think this setup would use DisplayPort 2.1, right? After all, both devices support the specification, so surely they would use that specification. Well, as it turns out, your DisplayPort 2.1 configuration might not actually be using DisplayPort 2.1 at all, completely defeating the purpose of buying that expensive monitor with the latest spec. So what on earth is going on here? Well, firstly, we hear a lot from you guys that you're interested in buying DisplayPort 2.1 monitors to benefit from this spec's higher bandwidth. Not everyone wants this, of course, but we get a surprising number of comments from people saying they won't consider a DisplayPort 1.4 monitor because it doesn't use DisplayPort 2.1. This is particularly common to see relating to high-end products where the display signal indeed uses a lot of bandwidth, like 4K 240Hz or 1440p 500Hz. The thinking here is that in buying a monitor with DisplayPort 2.1, the user doesn't need to worry about display stream compression or DSC and will get to enjoy the monitor with a fully uncompressed signal. Compression is often seen as this big bad technology, some people don't want to use it, and the issue has been exacerbated by NVIDIA GPU feature limitations that actually aren't caused by DSC at all, though DSC gets the blame. I've made a video on the channel previously that goes into detail on why DSC actually isn't bad and why in a lot of cases DisplayPort 2.1 is not a necessary feature. But I'm going to put that argument aside for a moment because some people are buying monitors specifically for DisplayPort 2.1 anyway, and those people would definitely want the monitor to actually use the DisplayPort 2.1 feature they've paid for. And when I say pay for, I'm referring to how DisplayPort 2.1 monitors are typically a bit more expensive than similar spec monitors that instead use DisplayPort 1.4 with DSC to carry the same signal. For example, if you want a 32-inch 4K QD-OLED from MSI, the version with DisplayPort 2.1, the MPG 322 URX, costs $1,000 US, with the occasional sale down to $900. The very similar MAG 321 UPX that uses DisplayPort 1.4 costs $800 with the occasional sale down to $700. In this instance, there's a $200 difference, and while not all of that is due to the addition of DisplayPort 2.1, it's typical to see a premium associated with this feature. As it turns out, if you're not using the right DisplayPort cable, it's very unlikely that the full DisplayPort 2.1 UHBR20 spec will get used. That's despite the monitor supporting DP 2.1 UHBR20 and the graphics card supporting DP 2.1 UHBR20, in this case, an NVIDIA GeForce RTX 50 series GPU. And you'll never know this is happening because the monitor will still work flawlessly with a silent configuration change occurring in the background to ensure your setup stays functional. To show this in action, I've used the Asus ROG Swift PG32 UCDM3, a 32-inch 4K 240Hz QD-OLED that supports DisplayPort 2.1 UHBR20. Carrying the 10-bit 4K 240Hz signal requires 68.6 gigabits per second of bandwidth uncompressed, which is something only DP 2.1 UHBR20 can handle. Then I've hooked it up to an NVIDIA GeForce RTX 5090, which also supports DisplayPort 2.1 UHBR20. Initially here, I'm using the right sort of cable, the short DP80 cable that comes with most DP 2.1 UHBR20 monitors. The cable is annoyingly short, but if we use this cable, set the monitor to its maximum spec, then check what DisplayPort configuration is being used in GPU-Z, we can see that the current link rate is 20 gigabits per second and that 4 lanes are being used. This is exactly how UHBR20 is supposed to work, 4 lanes at 20 gigabits per second each for a total of 80 gigabits per second, confirming that this configuration is properly working as full DisplayPort 2.1 without DSC. But what if you use a longer cable that you happen to have lying around because the included cable is too short? Or what if you simply use a random cable from that box of assorted cables that everyone has? This is where you might find yourself not actually using the DisplayPort 2.1 configuration that you paid for. Here's what happened when I hooked up a random DisplayPort cable I had in a box. As you can see, there's no functional difference using this lower quality cable. The monitor still works, it still allows me to set 10-bit 4K 240Hz, everything is working fine. If you didn't know any better, you'd think that because you hooked up your DP 2.1 UHBR20 monitor to a DP 2.1 UHBR20 GPU, that it's working using DP 2.1 UHBR20 without DSC, but that's not actually the case. If we explore this configuration in GPU-Z, you can see that the use of a lower quality cable has dropped the link speed from 20 gigabits per second to 10 gigabits per second. Still 4 lanes, but this is not a UHBR20 configuration. Instead, it's UHBR10 with a maximum of 40 gigabits per second of bandwidth. This is not enough to carry the uncompressed 68.6 gigabit per second signal, so DSC must be being used. And so in this configuration, with the use of this worse cable, there was no point specifically buying a DP 2.1 UHBR20 product because it's not even using that feature. Here's another test where I use a longer DP54 cable. DP54 is the class of cable below DP80. It's not quite good enough for UHBR20, but it is certified to carry 54 gigabits per second of bandwidth. Again, monitor works flawlessly, but GPU-Z indicates the current signal is still UHBR10 at 40 gigabits per second. It also tells us the max link rate that's supported has jumped up to 13.5 gigabits per second per lane. So it could use the full capabilities of the DP54 cable, but in this case, the active configuration is UHBR10, and DSC is still being used here. So what is happening here? Well, essentially, the NVIDIA 50 series GPU is testing the cable and using an optimal configuration to avoid problems, automatically without any intervention from the user. If it detects a lower spec cable, it will limit the maximum DisplayPort link speed, even if the monitor supports a higher link speed. This forces the display into a compatibility mode of sorts, where it operates using UHBR10 with DSC instead of UHBR20 without DSC. Monitors like this support all sorts of different link configurations so that they still work with older devices. You wouldn't want a situation where someone buys a DP 2.1 monitor and can't get it working on a DP 1.4 device, so older transmission modes are also supported. You might have wanted this setup to use the maximum and best mode, but this automatic process might be choosing a different mode instead. I suspect NVIDIA do this to prevent situations where GPU owners hook up a display using the wrong quality of cable and can't get it to work. If you actually try to force 80 gigabits per second through a cable only designed for 40 gigabits per second or 32 gigabits per second, the display may never power on. It could flicker, it could show corruption, or it could constantly disconnect and reconnect. Those are all typical problems from using a low quality cable. Instead of doing that and having to deal with support requests where users blame NVIDIA for their GPU not working with their monitor, they secretly test the cable and choose a configuration that will minimize issues. When you allow the monitor to use DSC, this process is seamless. Whether you use a DisplayPort 1.4 class of cable, a DP54 cable, or a DP80 cable, you always get 10-bit 4K 240Hz support with RGB color. The lower quality cables do so using DSC, and if you hook up a DP80 cable, it switches off DSC. But if you switch off DSC in the monitor's OSD, forcing the configurations to never use DSC, you can more clearly see the impact of using a lower quality cable on what that means for link speed and bandwidth. When hooked up to the DP80 cable, again, no issues. 10-bit 4K 240Hz using RGB color is supported with no dramas despite DSC being disabled. But when using the other lower quality cables, the GPU switches over to use a 40 gigabits per second link speed, and now 10-bit 4K 240Hz RGB doesn't work. Instead, you get 422 chroma subsampling at 240Hz, as there's only enough bandwidth for true RGB color at 144Hz or lower. And this is not some special mode of operation with this specific ASUS monitor. This is something I've observed across all DisplayPort 2.1 monitors I've tested to date. They all work just fine on an NVIDIA RTX 50 series GPU with lower quality cables, but you only actually get a proper UHBR20 signal when using a DP80 cable. So what does this all mean? Well, if you are absolutely set on using DisplayPort 2.1 UHBR20, you've specifically bought a monitor because you want that input, you want to use the screen without DSC for whatever reason, you must hook it up to a properly certified DP80 cable. If you don't use a DP80 cable, it almost certainly won't work in the UHBR20 mode. This is basically a public service announcement for the DisplayPort 2.1 enthusiasts out there to ensure they get the experience that they want. The best way of knowing whether you're using a DP80 cable is the branding on the cable itself. All of the certified DP80 cables I own, either ones I've bought or ones that have come in monitor boxes, have this DP80 logo on them, typically as a sticker. Vaser doesn't allow cable manufacturers to use this branding unless it's a certified cable. If it doesn't have the DP80 brand, it's probably not a DP80 cable and is probably not giving you the full DisplayPort 2.1 experience. The best way to confirm you're buying a DP80 cable is to check the product listing and confirm that product is in the DisplayPort DP80 certified cable database. You can access this database on the DisplayPort.org website, filtering the cable results for DP80 certified. It's not the easiest website to use, but it's the best method we have for verifying the validity of cables, because not all cable manufacturers are honest when they claim cables are certified or truly capable of 80 gigabits per second transmission. The DisplayPort list is the only true list. This video is not sponsored by any cable manufacturers or Vaser. It's just a video I wanted to make, but I have tested some DP80 certified cables from Silkland in a previous video, and they work perfectly, delivering proper UHBR20 link speeds even at a 2-meter length. I'll link to them and a few other certified options in the description below. I believe 2 meters is still the maximum length for a passive DP80 cable right now, so any cables exceeding that length are not going to be DP80 unless they use active technology. Now comes the part where I remind you that it really doesn't matter whether your monitor is hooked up using DisplayPort 1.4 with DSC or DisplayPort 2.1 without DSC. Display stream compression is a visually lossless technology, which studies have shown is indistinguishable from an uncompressed signal in the vast majority of situations. I've never been able to tell a difference between DSC on or off, even testing the two side by side, looking at them closely, I've just never been able to see a difference. Additionally, you don't need to get a DisplayPort 2.1 monitor to avoid DSC so that you can use all of NVIDIA's features like DLDSR. This feature limitation was never due to the use of DSC. It was due to NVIDIA's pixel throughput on a single display head. High pixel rate monitors like 4K 240Hz would exceed a single display head, forcing the combination of two heads, and this prevented some features from working. It just so happened that the single head limit was very similar to the bandwidth limit for DisplayPort 1.4 without DSC, meaning that in the majority of cases, when a monitor needed to use DSC, it would also exceed the single head limit. Hence people associating the use of DSC with feature limitations, even though it was actually never about DSC. On the NVIDIA GPUs that actually support DisplayPort 2.1, so the RTX 50 series, the display engine was massively upgraded and the single head limit doubled. This gives users full feature support on many more high pixel rate monitors, and crucially, you get this support regardless of whether you're using DP 2.1 or DP 1.4 with DSC. You don't need a DP 2.1 monitor to benefit from this improvement. You should see full feature support using either of these connection technologies. Anyway, that's enough for this video. Just a quick PSA, because I am still seeing those comments about people wanting to use DisplayPort 2.1, buying monitors specifically for this feature, and I thought, well, you guys should probably realize that you need to be using the right cable for this feature to even work properly in the first place. So yeah, now you can be armed with all the information that you need. And it should be particularly useful if you don't like the short cables that come with most of these monitors, but you still want to continue using DisplayPort 2.1. If you do want to buy a longer cable, you do need one that's DP80. Otherwise, you're just not going to get DisplayPort 2.1 UHBR20 working. The monitor will still work, as I've shown in this video, with other types of cables, but if you want the full bandwidth, no DSC experience, you do need a high quality cable. So anyway, if you want to support Monitors Unboxed and all the testing that we do here, there's Patreon, links to that's in the description. You guys know the drill. I've also, as I said, linked a few cables down there that I know are DP80 certified, so if you want to purchase those you can, but it's not really necessary. As I said, DP 1.4 still works just fine. So that's it. Thanks for watching. I'll catch you in the next one.